Okay, I'm back, and I've done the experiment and I've collected the data. So I'm going to now give you the data for columns 1 and 2 of the first data table. And then you're going to calculate the answer that goes into the third column of the data table. So for star number 1, I think what I'll do is I'm just going to give you all the numbers in column 1. So for column number 1, you should have 2986.7 for star 1. Then underneath it for star 2 is 3316.7. Then for star 3 it's 3650.1. For star number 4 it's 4023.4. For star number 5 it's 4370.1. Now we're ready for column 2. So for column 2, star 1, 3283.4. Star 2, 3620.1. For star 3, 3950.1. For star 4, 4323.4. For star 5, 4670.1. So those would be all of the different times that the stars entered the field of view, and then the time that the star exited the field of view. So you're going to subtract each of those numbers. So for star 1, take the time that it left minus the time that it came in, and then put that in the third column. And then repeat for star 2, 3, 4, and 5. Okay, I'm going to give you the answers. So let's see how close you got. So for star 1, the transit time was 296.7. For star 2, it was 303.4. For star 3, it was 300. For star 4, 300. And for star 5, 300. Okay, so you got those numbers? Okay, now we're going to go down to the second chart. So go down to the second yellow and blue chart. It says to find the average transit time. So you're going to take each of your 5 transit times from the first chart, add them together, and then divide by 5, and put that number under the average transit time. And the number should be 300.02. Okay, then the next number is to find the average transit time in seconds. So how many milliseconds are in a second? Well, how many millimeters are in a meter? 1,000. So you're going to take your number for the average transit time and then divide by 1,000, and then put that in the next blank. And so that number ought to be 0.3002. Okay, now for this next part, you definitely have to have a calculator. We want to calculate the angular width of the field of view. And in order to do that, we're going to use the equation that is up above it. So up above the chart that you're currently filling in is a formula that says angular width divided by 360 times 3,600 is equal to average transit time divided by 86,400. So that's the equation that you've got to solve. So you know what the average transit time is. So take that number, plug it into that formula, and then solve it for the angular width. I'm waiting. You might need to turn me off. Okay, got it? Are you expecting me to give you the answer? No. All right. Now, what I got was 4.503. Now, the way that I did this was I kind of cheated a little bit. What I was supposed to do was to wait until the star made its appearance, and then I was supposed to note the time, and then note the time when it completely exited. Well, the problem is trying to anticipate when a star is going to make its appearance. So what I did was I waited until the star got to the end of the first grid, and then that's where I stopped it, and then I noted the time, I started it, and then it went all the way across. So what I measured was not 10 grids, I measured 9 grids. Okay, because the next thing that you need to calculate is the angular width of one of the grids, one of the divisions. So if the average time or the average angular width of the field of view going for 9 of the grids was 4.503, then what should I do if I want to know the angular width of just one of those grids? Okay, I'm going to take the 4.503 and divide by 9. And so that turns out to be, go ahead and do it. Okay, that turns out to be 0.5003. So that's the number that goes in that last yellow box, the angular width of one division on the grid. Okay, so now you should have all of that filled in. Okay, so now what I'm going to do is I'm going to stop the video, and then when we come back we're going to go to part 2 of the lab, which is entitled Stellar Parallax, Measuring Stellar Parallax. Okay, so I'm going to stop the video here, and then when I come back I'm going to show you the picture of what you should have done in lab.